The Electragalene 3-gate lock comprehensive water management system. Developing a combined water management system to act both as a flood prevention pump when required and renewable energy generator for the remainder of the time. Being fully reversible, it can work equally well in tidal, combined tidal and river-only environments, and is scalable for any size. The system can allow the safe passage of eels, fish, even boats and large floating debris, such as tree trunks, to pass without damage. It combines flood prevention and energy generating capability into a single comprehensive water management system, paying for the capital installation cost through the sale of renewable energy. The system is able to switch directly between the required functions. Being fully flexible, it can be designed in the form of conventional lock gates or other means such as rotary valves, where the passage of boats is not required. In each case, the centre gate or valve moves backwards and forwards between the two outer ones to pump or extract the energy. The device is presently shown operating as an energy generator, where the higher upstream river drives the moving gate in a sequenced way demonstrated by the animated diagrammatic. Each power cycle occurs in two parts, firstly at constant head, and secondly with reducing head at constant volume. This is a most efficient way of extracting the available low head hydro energy. Between each power stroke, the opened or flowed gate is moved back to repeat the cycle. By changing the gate sequences, and depending on the centre gate being driven, driving or fixed open, the device can pump out excess floodwater, isolate the river from the estuary, or allow a full throughput flow of water. The animated diagrammatic now indicates how the change of gate sequences has modified the mode of operation. By applying rather than extracting energy from the centre gate, the device becomes an equally efficient high-volume flood protection pumping system. Again, the cycle consists of two parts. In this case, first raising the level of a volume of water and then delivering this to a higher sea level side. The pumping head is low, but the volume is high, providing maximum flood protection pumping efficiency. A major flooding problem in tidal estuaries is the backflow of seawater upstream during high tides. The backflow stops the outflow of river floodwater and backs up the volume with seawater for a considerable period during each high tide. The AmperWave device not only prevents a backflow of seawater, but also provides uninterrupted flood protection pumping. Additionally, the device has no preferential input or output designation, enabling all functions to operate equally well in both directions. Therefore, for example, when the river is not flooding, the seawater backflow upstream during each high tide can become part of an increase in the energy generating cycle. Similarly, pumping seawater upstream into the river can be used as an energy storage facility for time-shifting energy output in line with periods of higher demand. Conversely, flow can be stopped in either direction by closing all or just any of the gates. Isolating the river from the estuary is sometimes necessary for maintenance, weed clearance, dredging or biological reasons. Preventing a contaminated spill upstream or downstream, for example, can be achieved. Conversely, all three gates can be fixed in the open position. This allows both river and tide to have a full bore unimpeded flow. With a free flow, fish and other species are able to migrate freely during periods of spawning, for example. The unimpeded flow can also help with flushing of silt and cut weeds.